Bismillah ar-Rahman ar-Rahim. This is a paper, June 2020, 43 variant, and paper 4 complete. We're going to solve. First question we have here, the particle of mass m. And best way in exam, this paper is a very tough for those students who have no habit of reading, okay, proper reading. So if anything misread, question become wrong. So that is why you have to either underline the way I'm underlining or write data. Okay, P mass m kilogram, Q mass 0.2, free to move smooth. Smooth means very, very clear. Friction is 0. P is projected at a constant, at a speed of 2. Okay, so speed of the P, and Q towards Q, which is stationary. The Q is stationary. After collision, P and Q move in opposite directions with the speed of 0.5 and 1 respectively. So let's start. So it means they are two objects, very clear. P particle mass is m kilogram, Q particle is 0.2 kilogram. And this speed is, given by him is 2 meter per second. And this is stationary. So this is just before collision. And let's talk about after collision. So after collision, what this situation is, he said they will move in opposite direction. So naturally, definitely they're opposite direction. So 100% Q will go this way, no doubt about it. Because first it was stationary, so its speed is 0. This U1 is 2. But it's stationary. So when we, after hitting, no way this Q will go this way. So 100% Q will go this way. So if Q is going this way, so P will go backwards. How I know? Because he said that they move in opposite directions. So this condition is very clear, and speed of P and Q both are given by him. So V1 is 0.5, V2 is 1. But make sure point is not a 0.5. This is negative 0.5. Now it is interesting. Most interesting point is this, because let's say observer's eye is here. If observer's eye is here, so naturally the thing which goes away from observer, so velocity always positive, and coming back to observer, velocity always negative if observer's eye is here. I hope so you got my point. So I think this part is easy. Then you can apply formula. What is law of conservation of momentum? M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Mass of the first particle is m kilogram and speed is 2. Second speed is 0, it gone. Mass of again is m kilogram and speed is V1 is a negative 0.5. And second mass 0.2 and speed is 1. That's it. We can solve it. So this will come here. So 2m plus 0.5m. And here I got 0.2. This becomes 2.5m equal to 0.2. So finally, this 2.5 will divide. And as it will divide, so if we type in calculator 0.2 divided by 2.5, 0.08 kilogram. So Alhamdulillah Rabbil Alameen. I hope so. First question is completely over. So question number 2, we have the mass of a minibus is given 4,000 kilograms, traveling in a straight horizontal road, and resistance to motion, so the friction is given by him is 900. And the find driving force, so driving force is our task when acceleration is this. The best technique, either write data or on the question, mark their values. And please draw the diagram, although this is not important diagram to make it, because applied force and friction force acting down backwards. Basic formula, what we have, net force equals to MA. So applied force is capital F, friction force, small f, equals to mass into acceleration. Applied force is my question, friction force is 900 newtons, mass is a 4,000, and acceleration is 0.5. And this become half of 2,000. 0.5 into 4,000 give you 2,000. This 900 will go there, so now 2,900. So applied force is 2,900 newtons. I hope so. First part, there is no confusion at all. So let's go for next part. In next part, what is the situation? Yes. The next part is given us the power required to minibus to maintain is a constant speed. And you know, whenever, so power is a question mark for sure. Maintain constant speed and off 20. It means acceleration for sure zero, because if there's no velocity changing, acceleration is zero. So same formula by apply, capital F, same net force equals to MA. So I can say applied force minus friction force equals to MA. So applied force minus friction is equals to zero. But now current situation, we have a speed is concerned. Speed is given and power. So in this option, we have a power formula we have to involve. If you recall, power formula is work done divided by time. But we have another formula, work done is a force times to distance. And if I divide distance by time, it gives us speed. So this formula I will use here. So speed, velocity will go there. So I got P by V equals to capital F. So this formula I'm going to use here. And friction goes on other side, and power, and this V will multiply there. So short story, friction force, which is 900, and times 2 speed is a 25. So alhamdulillahi rabbil alameen, 22500 watt. But we are looking kilowatt. So you know, 3 decimal jump, 1, 2, 3, because 1,000. So 22.5 kilowatt. So alhamdulillahi rabbil alameen, I believe the point is very, very clear. Question number 3 we have, he said system is in equilibrium. Whenever system is in equilibrium, so we can say here, rightward forces equal to leftward forces, upward equal to downwards. So first, before you solve, I have to resolve. Every force has two components. You can see this is angle 60, force 40. So angle, I'm writing 60. So students, this is a 40 cos 60. because force and angle. And this become 40 sine 60. And let's talk about this. This 30 given here, so this angle is 30. And I said before, when angle given, that is always cos component. Another becomes sine component. And this is F acting alpha. So one parallel to x-axis and one parallel to y-axis. Alpha is given here. So where alpha, that is a cos. And where not given alpha is sine component. Now let's talk about fourth, sorry. So this is a 45-degree force and angle used together. So 50 cos 45, 50 sine 45. Now I think this job is, and I suggest the teacher, please show these all components on diagram, because at least 3 marks or 2 marks or 3 marks for this showing components. So now he's saying find alpha. So I will say left side forces are these two, right side forces are these two. So they are balanced. So I can say here, first I talk horizontally. So F cos alpha plus 50 cos 45 is equals to 40 cos 60 plus 20 cos 30. Again, these two coming here and these two addition coming here. All right, so bring this force also there and make F cos alpha alone subject, I mean to say. And this idea, you can type all together. So this will go there and I'm typing parallelly. 40 times 2 cos 60 plus 20 times 2 cos 30 negative 50 times 2 cos 45. Students, so when I'm typing calculator, so I'm getting 1.9. Some student write 1 dp or 2 dp. No, 1.9652. At least 4 dp you should write for accuracy. So I hope so this part is very, very clear. Now I'm going for vertically. Vertically. So these two forces acting upwards, these two forces acting downwards. So F sine alpha plus that top one, 40, 60, 40 sine 60. So these two forces. So 50 sine 45 plus 20 sine 30. Now this force I will bring on the other side, and at the same time I will type. So student, 50 times 2 sine 45 plus 20 times 2 sine 30 and negative 40 times 2 sine 60. If you type it again, I tell you, don't type 1 dp. Minimum 4 dp's you must type for accuracy. Now you know, students, what is the basic criteria? Sine up, cos down will give you 10. Sine divided by cos. So 2 divided by 1 will help us to solve. So F sine alpha, keep it up. So 10.7143 will come up. And F cos alpha down, 1.9652 also down. Repeat, this up, this down, this up, this down. So this F cancel out and I get tan alpha. And this you leave as it is or type in a calculator. Yes, always it depends upon the thing because sine up, cos down. We have a tan comes only with a, some student may ask us, so can I keep cos up? No. Cos up, sine down become cot. Cot is not in syllabus of AS level. So tan is in our syllabus. Now if I take tan inverse, so I am taking tan inverse and 10.7143 divided by 1.96 and 52. So yes, and I'm getting here 79 point. And again, important thing is here. Best idea, you should write long answer, at least 4 DP. And only reason behind it what? For accuracy, we have to type it. So, so it means this one, this and but rounding giving you alpha what? 79.6 degree. But when I use this angle in the any one equation, I will not use rounded one. I will use this one. So this will go there. So put in 2 or put in 1. So F times, so 10.7143 divided by sine of 79.6064. This will give us accurate answer. So let me check, student. 10.7143 divided by this. So I'm getting 10.89. Rounding give you, so Alhamdulillah Rabbil Alameen. In this way, we get an accurate answer due to 4 DPs. 4 DPs, 5 decimal places, also good choice. So let's go for next. Yes, students, question number 4 we have. Car starts from rest and move a straight line with a constant acceleration. All right. And for distance of 550 meters, the car then is, it means the first situation here, you can say that first according to situation. First I'll draw a rough and then I'll draw like the sketch word is there. Sketch is itself rough meaning. Anyway, so you can see this is a okay. This is a distance 50 meters according to situation. Start from rest and its acceleration is a, and for a period of 25 seconds. Sorry, no, that is separate part. The car start from rest, it means starting from rest. Constant acceleration, so constant acceleration. Like, sometimes there are two kinds. This is a curve, this is acceleration changing. Here different, here different, here different. This is not a constant, it's called variable acceleration. There's also a variable, there's a different and different and different. But when he say constant, it is always straight line. So it means constant acceleration means straight line. And whenever constant acceleration given, we can apply equation of motions. Okay, apply equation of motions, or we can apply two more rules. Rule number one, the gradient of the line is actually is acceleration in velocity time gram, and area under lines is equals to distance traveled. This is a very clear concepts we have to. So whenever constant acceleration, so these conditions we can apply. Let's start. The car then travels the constant velocity. Now no more constant acceleration is set. And constant velocity means, acceleration becomes 0. No velocity changing. For how much time, students? Of 500 meters. And how much period? 25. It means, let's say this is continue. Okay. And this gap is 25 seconds from here till here. and distance how much traveled 500 meters. So this is because this is a constant velocity. All right. And here acceleration, you know it very well, zero, because velocity is not changing. Okay, then decelerating for rest. Okay, but before I start next drawing, because some parts are required. Okay, and he said find. First of all, I think I can find and then it given us the one more the important thing given here. Uh, okay, wait a minute. Yes, this time is given and distance given. First data is not enough. Second data is enough. I will use what is the formula? Because constant speed, constant velocity, we can use this formula. Distance is equals to speed multiplied by time. This formula applicable especially these conditions when we have a constant, okay, given. So let's start. Distance is of 500 meters. You know it very well, students. Speed is unknown and time is 25. And if I divide this 500 by 25, I get 20. So V velocity speed is coming 20 meter per second. So it means this speed is here. Wait a minute. This is creating a trouble. Okay. So I mark here 25, sorry, 20 meter per second. It is okay. Uh, Now he's asking for acceleration. But before I want to tell you one thing, if you're doing rough idea even, this line is very important to understand. Before decelerating the part to rest, 100% particle will rest, stopping here. But I don't know it stopped here, it stopped here, it stops here, it stops here. How? Because this is a even sketch, but we have to draw a good sketch. This line is helping us. The magnitude of deceleration is 2a. If this is a, so this is double a. Very interesting. I just tell you one thing, and this keep in mind: if acceleration is a and deceleration is 2a, repeat my words. If acceleration is a and deceleration is 2a, so if its time is t, this time always half t. You ask why half t? Because it is acceleration is double, it will take half time as taken as a before. So let's say this time is 10 seconds. Here it will take 5 seconds. If this time is 20 seconds, this time will be 10 seconds. Rule. And second option, one more idea given. If acceleration is A and deceleration is triple A, 3 times 2A, then if this time is T, this time will be 1 over 3T. I believe you got the point what I'm saying. Okay, triple, because triple, so what is the time there? For example, is this 15 seconds? 15 divided by 3 become 5. So this will be 5. So that is why this is a separate example. I given you extra example. So what is the question? We are doing half t. So it means what the gap here, student? Make it half gap and draw here, sketch here. Now I hope so you realize that why this gap is more and why this gap is half. This is very important. What I believe, if you will show this gap and this gap equal, you will lose mark maybe here. Okay. All right. So best idea, show the gap. But I think no one mark is there anyway, but don't give chance to cut marks from here. Okay. So this sketch is completely done now. So I hope so. This concept is very, very clear. And let's talk about acceleration. Here you can acceleration I discuss on the top is called gradient. You can use gradient or you can use equation of motion even. So let's start. Uh, this is a time t1. This is a time t1. So it means from here 0, 0 coordinates. And what is this time from here to here? Time 1. So what are coordinates of this? T1, comma 20. Reason, because this x value here is T1, so this T1, and y value here is 20, so that is why this is a coordinate. So what is the acceleration formula, gradient formula? Y2 minus y1 over x2 minus x1. And gradient stand for acceleration. I'm putting A. Y2 is 20, y1 is 0, x2 is T1, and x1 is 0. Okay, I got it here. It means this is not enough data. We have to utilize this 50 also. And what is the distance formula? Half into base into height is equals to area. Half base is what? T1. Height is what? 20. So base is a T1, height is 20, area is 50. So this A equal T by T1, and T1 I will get from here. This is cancel 10, and 10 goes down, I get a 5. So Alhamdulillah Rabbil Alameen, this time is 5. Now common sense, if this time is 5, then this time will be naturally 2.5, half of it. Anyway, this time will come here. So 20 by 5. So A is coming 4. This is we have another formula. Even you can use the other formula, V square minus U square equal to 2AS. Final speed, 20. Starting speed, 0. Acceleration is missing, but S is 50 meters. Rather than doing the whole working, you can do shortcut even, apply this formula and get answer. So I hope so. You understood both ideas. Let's go for next. Total distance for total time for the whole journey. I think the total time is confirmed now. You see, this time I got it. This time we have it, and this time we can find it in easy way. And that is the time I said before, right? As acceleration is 2a. So time will be half. Half of acceleration time. Sorry, as deceleration is 2a. So acceleration, half of acceleration time. And what is acceleration? So it means what is the time for deceleration? Is and this time is 5 by 2, and time for deceleration is 2.5. So total time, how much, students? Is first time for this is 5 seconds, then 25, and now I got the other one. So 5 plus 25 plus 2.5. So I got 32.5 seconds. So Alhamdulillah Rabbil Alameen. And I believe you got a point very, very clear. So next question, we have a number 5 here. The block B has a mass 4 kilogram, as said before. So please either you label it like this or mention, so you can your eyesight can catch the values easily. Smooth plane, you know it very well. Friction is 0. So theta is equals to given 30, and horizontal, okay, applied to B in a direction of the P. Okay, block passes through P and Q. Speed at P is given 12, and speed of Q is given by him is 8. The sake of clarity, I will write top. VP is 12, VQ is equals to 8. Chances of mistake in this way reduces. PQ 10 meters apart. So S is 10 meters, and P below the level of Q. All right. So let's draw a rough diagram, so at least you can realize Okay, this is 30, and let's say P is below, he said. Let's say P is here and Q, imagine here. Even you can imagine the middle, even both part positions, no problem at all. Distance throughout 10 meters from here till here. And particle if is here, one option, or particle is here, second option. So speed at the top, this is here, is 8. So this speed VQ is 8 and VP is 12. So it means speed is decreasing. And he said decrease in kinetic energy of the block. So this is simple, I think, because you know it very well, students. Kinetic energy is a half mv square. So let's see what is the decrease. Decrease, actually we will just normally use uh, ending minus starting. So kinetic energy half mv square on the top, q particle half mvp square. Okay, although I wrote decrease, so it is a negative sign covered, but then you can write vp before and vq later on, no issue at all. Just have m common from both. Okay, and vq minus vq squared minus vp squared. So mass is 4 kilogram and vq is 8. You can see this vq and v at 12. You see, easy to get this values. So I'm typing into 2. I got negative 160, and negative 160 is so I will joules. I will remove the negative sign. So what is decrease, students? So decrease in kinetic energy is 160 joules, because decrease itself negative sign. So no need to show negative sign. Now work done for the force pushing the block up. We have to find work done and move from P to Q. So this during this whole process, what is work done? Now we have many techniques, but I always use a magical formula. Um, Actually, formula is basically what formula? What is these positions starting and ending, starting P, ending Q? Formula always write like this: work done by applied force, work done by frictional force, kinetic energy plus potential energy at the end point Q, kinetic energy plus potential energy starting point P is ending, is starting. And this formula will, you can use this formula in all options, okay, where we have a work done applied for friction given. So you know friction force is 0, so alhamdulillah this becomes 0. And for your knowledge, uh, if I expand the formula, what happens? Work done by applied force. This is 0, you know it very well. Kinetic energy at Q plus potential energy at Q, kinetic energy at P minus potential energy at P. So, but you know it, kinetic Q and kinetic P, we just found it. Hmm? So I will bring together kinetic energy of Q minus kinetic energy at P, which we have already. So it means in the place of this, you see Q minus P, I will plug in directly minus 160, because this kinetic energy Q and P, same formula I have already. So what student left behind? Potential energy at P, that is definitely 0. Logic, the height of the P particle is 0. And if you know what's potential energy formula, students, mgh. If h is 0, so it means, so potential energy at P is 0. This is a just take of your knowledge. So I have left only potential energy at Q. You saw, so easy we approached on this concept. Nothing to do extra with it. Now, what is the potential energy formula? mgh. Mass of the particle is 4, G is 10, H is left only. Now, where is H? Come on this diagram. So I show you this is called H, 90 degree. And this is 10 given, this angle given, I think SOHCAHTOA, I can find it easily. Opposite by hypotenuse is sine theta. That's it. And I will find it here. H over 10 equal to sine 30. And sine 30 is a half. You know it very well. Sine 30 is a half. Half of 10 will give you 5 meters. So it means because 10 times sine 30. So Alhamdulillah Rabbil Alameen, MGH, H is 5 meters. So Mabruk, so just a matter of typing 20 into 10, 200 minus 160. An answer is coming, work done by applied force, 40 joules. So Alhamdulillah Rabbil Alameen, I believe you got it very easily. Part number next, at an instant the block reaches Q, the force pushing the block is removed. Applied force becomes 0. And find time taken. So time is my concern. When return back to P. Okay. So distance traveling is 10 meters. It means first it was going up. Now it is coming down. I show you again. So first is back to return to. So this is a Q, this is a P. Now it will travel downwards naturally. Okay, students. So height also remains same, but distance is also as 10 meters. Okay, angles 30. So how to find it? Because time S, what is missing, students? Now velocity will not remain same, but starting, because it says removed, so it start moving downwards. So starting speed is definitely 0, because then it will come downwards. I hope so you got a point clear what I'm saying. But interesting part we have here, what I'm going to discuss with you. What is missing? Acceleration is missing. If I get acceleration, my question will be finished. So let's start. Look at here, students. This is a particle and mass of 4. So this is a 40 newtons. Now, why convert 40? Because the weight will act a very important character here. What is this? All of you familiar? This is the weight sine component. So 40 sine 30. And backwards is friction if motion downwards. So we can find acceleration from here. Net force equals to MA. So 40 sine 30 by minus friction, but friction is 0. No need to avoid friction, equals to mass is a 4, and acceleration is my target. Sine 30 is half, half of 40 is 20, and 4a. So acceleration is coming with us 5 meter, 5, very clear. So acceleration is clear. So it is a clear afterwards. What he's asked, we have to find it what? Time taken, okay? And 1 minute, please. It is going up or down? Wait a minute. Pushing up, I think, instantly reach Q. Force pushing the block up, the slope is moved. This, oh, sorry. I thought force is moved. No, 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 no. At an instant, the block reaches Q. Q is the top. Okay. Sorry, students. I read the question wrong. At the instant the block reached Q, on the top, he said the forces of pushing block up the slope is removed. So forces of pushing is gone. Time taken for instant the block return to P. Okay, so you know what happens, students? It means the situation is slightly different. almost same, you can say that, but I give you the diagram once again. Inshallah, I believe you will understand. Wait a minute, please. Situation is what, students? Sorry, I done in a, okay. So it means first it will go up, then it will come down. It means, let's say P position is this and Q position is this. So when particle reach from P to Q, at this moment, applied force gone. So do you think it will stop here? No, it will go slightly up and it will stop here. And this motion is called motion due to inertia. Here, applied force gone. And this motion is called motion due to, or you can say inertia motion. What is called inertia motion? When you, this is a car, you are pushing, okay? When you're pushing, for example, and you stop pushing, then it is moving, and but it will stop pushing. It will not stop there. It will go slightly forward and then stop. And this motion is called motion due to inertia. So I hope so the concept is clear. So let's try to complete. It means I need to find this because time taken is important. And then it will stop there on the top, and then it will return to P. It means starting from the top and then coming down. So two motions. First, it going up, and then I will make another diagram. And then from P, sorry, that's from peak or from the top. This is a last position where it will, from last position, it will come downwards and it will reach P. So this is our concern. So we need to find two times, this time separate, and this time we need to find separate. Interesting. And last velocity is confirmed zero. And very interesting, what is velocity of Q? We got it before we have it. T V Q is 8. This U VQ had become as a U. So this is behaving this as a U. So U is equals to 8. For the motion due to inertia, students, this velocity will behave as a starting speed. Okay, when it was traveling from here and here and here, reach here. So what is the ending speed for this motion will become starting speed for this motion. So U become 8 for this motion, but still something is missing. Let's talk about inertia concept. So I'm writing here inertia situation. So U is 8, final velocity is 0, and time is my concern, but I need to find acceleration. The way I found before, students, same way I'll find acceleration, okay? And what is the switch condition? Let's say a particle, applied force is upwards and friction force downward plus mg sine theta. What is the mass, students? You know mass of 4 kg. Then what is weight? 40 newtons. So this is a 40 sine 30. Because whenever it plays an angle is 30 degree, you know that is the reason 30 coming here. So any particle placed on the inclined plane is the weight acting is this way. One is acting downward, but along the plane is always 40 sine 30. You know it very well. But now system is going upward, students, motion upward. And I'm looking at this acceleration for this part. So when force is removed, situation is that when applied force is removed, when applied force removed means capital F0. So net force is equals to MA Applied force is 0. So what's the first formula? Applied force minus friction force minus 40 sine 30 is equal to mass 4. Acceleration, I don't know. But you know, F and both F's are zeros. Smooth, so both are zeros. 0 minus 0. 40 sine 30 giving you what? Sine 30 is a half. I got 20. 4 goes down, so I got negative 5. It means this deceleration here, negative 5. So Alhamdulillah, I got it and I can find easily. So time to going up. So V is equal to U plus AT. And last velocity, you know, it stops. So V0, U at this moment is 8. I'm writing 8. Acceleration negative 5. And time is becoming is 1.6. Let me check. 8. Yeah, 1.6. So 1.8 second is a time for this. It means while where hair force removed. Okay, students. So 1.6. And now from top to down, I will find second time, T2. So T1, I got it. This I given name T1. T1, I got it. Now I go for T2 and then add them and question will finish. All right. So let's go and make sure one thing I tell you, students. Whenever smooth surface is there, I repeat my word, smooth surface. Okay. Particle going up or down, acceleration remains same, only sign will change. It means, let's say going upward, acceleration is negative 5. Same particle going downwards, acceleration remains same, but sign changes. Why? Going upward, it will slow down, and coming downward, it will going accelerate. So A is 5. So that is why now I'm saying that while moving downwards. So moving downwards, downwards. So what is starting speed from here? It will stop definitely and then moves downwards. So U0 and S is a, now very interesting, S is missed. So it means I will find S also. Why S? Because you know, this distance, and for tell me, I tell you, okay, P is this point, Q is somewhere here. Okay, this P to Q, I know 10 meters, I know it, but this distance, I don't know this distance. So it means I need to find this S. So I think I can find easily, not any hard job for us. So I am shifting it slightly left side and I'm finding it here. And that is a easy. Okay, so 2AS equals to V square minus U square. Going upward, negative 5S is target, V is 0, U is 8, S is becoming negative 64 divided by negative 10. So it means is a 6.4 meters. It means it is 6.4 meters. So this is the clear. Now let's go for, it means 10 and 6.4 meters. Okay. It will travel in now in two options. So I hope so up till here, you're not getting any issue. So let's see. So this is, let me recheck once again, 2 negative 5S U0. Yeah, correct. 64 by 10. Yeah, 6.4 meters. Correct. So now students, this is 6, this is a 10 already. This 6.4. Then total distance while traveling downwards U0, S is 10 plus 6.4. S will be 16.4. And acceleration, as I said before, remains same. Only sign will be positive. And what is my concern? Time taken. So time is a concern. So, you know, S is equal to UT plus half AD square. So U is 0, is 5, and time is my concern. And S is how much, students? 16.4 meters. So this is, so I get T square what? 16.4 into 2 divided by 5. I'm getting 6.56. Take a root and I get a time, how much from here? 2.56. And this time, in the top time, I will take together reason. Reason is very clear because total time is asking for going upward and then coming downwards. So if we type in calculator, 1 minute students, I'm typing in, and total time is coming with us 2.56 plus 1.6. So 4.16. So total time is coming with us 4.16. I'm writing finally. So total time T1 plus T2 is a T2 actually. It's T2, 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 and T2. T1 is 1.6 and this 2.56. And answer is 4.16 seconds. It's a really good question. I repeat again, what happens, students, when he removed the force? Practically first it was going upwards. When it reached Q, so applied force gone. So after this Q situation, it will go slightly above due to inertia motion, and then it will come downwards to come same position P. So going upward, and we'll find time and then coming downward. So Alhamdulillah Rabbil Alameen. I hope so the point is clear. So let's go for next question. Yes, student, question number 6. Particle travel in straight line PQ. The velocity given by the P is formula is given here. And student, make sure whenever this formula given is a never constant acceleration, then equation of motion we can't use. We are bound to use this equation only. And when this kind of equation comes, expression comes, we can use this criterias. Displacement, if you differentiate, you get velocity. Differentiate, you get acceleration. So differentiate, differentiate. And if you integrate acceleration equation, expression, you get a velocity. So integrate, and again integrate. This criteria will use in the situation when he give us this kind of equations. Find the velocity of the particle at an instant when acceleration is 0. But problem, do you have acceleration expression? No, I am on the velocity level, but I need acceleration. So if I go from this level to this level, I will differentiate. Bismillah ar-Rahman ar-Rahim. Differentiate. Acceleration equals to what is derivative? 4.5 becomes 0. 40 become 4. And 2 comes down, we got a 1 and T only. So yes. And what is saying that acceleration 0. So I will put acceleration is equals to 0. So this 0 equal to 4 minus T. So T becoming 4 seconds. But what a question he is asking. Instant. Instant means time. When acceleration 0 at that time, find velocity. So this velocity with this time, I'll plug in back an equation. So V equals to 4.5, 4 times to 4, and 0.4 to 5 times to 4 squared. And this give us answer. And I'm typing my calculator, 4.5 plus 16, negative 0.5 times to 16. And answer is coming 12.5 meter per second. So at that moment, when acceleration becomes 0. I hope so. The point is very clear. Let's go for next part. The particle come to at rest. Particle comes to at rest at Q. Rest means very clear. I will plug in velocity is 0 to get a time when it is at rest. Okay. And then find distance between PQ. All right. Interesting part for 6 marks. So first of all, I will take equation. Equation is V equals to 4.5 plus 4T minus 0.5 T to power 2. Let me check. Yes. So this equation, I take it down here. So let's see. So in job number 1, I will, because at rest, as said at rest, to put velocity equals to 0. When I put velocity 0, students, so I get 0 is equal to 4.5 plus 40 negative 0.5 t to power 2. So you rearrange. So it is coming 0.5 t square positive, 4t negative. I multiply whole equation with -1. It's not a compulsory part. Okay, anyway. So in this way, if I apply quadratic formula, I will get time. So negative b plus and minus b square 4a into c, but c is negative over 2a. Make sure, students, at least this step is you have to show to examiner. Afterwards, even you, if you use a formula available in your calculator, examiner will not mind it. Okay, so answer is first answer is coming 9, second answer is coming -1. So it means it is made very clear. Particle stops at 2 points, but this is not in our range. We should leave it in Q only. Now, question coming, distance, find distance when it is a like 0 to 9. Yeah, exactly. Because students, this time ignore we have to ignore. So it means distance travel, and all of student, look at here. If I'm on a velocity level, I need distance, so I will integrate. So I will take this expression once again and integrate. So have job is over. Again. I will take it here, and you know it very well what I'm going to do. This is gone, or I can say even leave as it is. When I integrate, students, both sides, here I get S and 0 to 9 limit, because starting from 0 and they can 9. So 4.5. Yes. Or write in order even, or leave as it is. No problem at all. Okay, students, no effect is coming. So let's start. What is the rule of integration? 4.5 become 4.5t. 4 increase the power by 1, so 2 by 2. Then this is 0.5 increase the power by 1, so 3 by 3. Lower limit 0, upper limit 9. Now I'm going to replace. When I replace upper limit 9 throughout, so let's see what answers coming. I'm putting 9 here, here, and here. And 0, no need to put. When I plug in first, I'm getting 40.5. Then I'm getting 2t square. I'm getting 162 and negative 121.5. Final distance is coming 81 meters. So I hope so. The point is very clear. No need to plug in 0 because giving 0. So I hope so. The concept is very, very clear. And let's go for the next question. So next question we have here, question number 7. And what a situation we have, if you read a question carefully, particle 2 mass given 13m. So best technique, a lot of long story we mention here. So mention the situation. So a particle is 3m kilograms. B particle is 2m kilograms. Okay, and he mentions what here, string passes over smooth pulley. Pulley always smooth in our whole syllabus. And plane is inclined at theta, you can see. And A lies in the plane, B hangs vertically. You can see it is hanging, and there's a vertical on the plane. Okay, there's an inclined plane. 0.8 meter above the ground, and which is a horizontal ground is here. The string pass between A pulleys parallel to the So this is a parallel, you can see slope. Initially AB at rest. So both velocities in the beginning are 0. Given that the plane is smooth, it means A part. So maybe second part, it may be rough. So first part I will take is smooth. So Alhamdulillah Rabbil Alameen, friction gone. Okay. Find the value of theta for the A remains at rest. So it means our concern is like system rest means, what does rest mean? Student acceleration is 100% 0. So let's start. So the first part, what we have here, what is a mass to 2m? Weight becomes 2m into 10. So this becomes 20m. Tension will be towards pulley. Okay. Same way, this is done. Same way when talk about this, tension toward this, make sure tension is always towards pulley. When about talk about this, it has two component, is a weight is 3m into 10, 30m. So this is 30m sine theta, because this theta. So always this rule. Okay. So now, because system equilibrium, I can make two equations first from here, because system is not moving. So this force and this force equal. I can say that from B, I can say T is equals to 20m. And now from A, I can make it this up and this down. So T equals to 30m sine theta. All right. And I can replace this 20m value here. So solving them simultaneously. Okay. This mass and mass cancel out. 30 will go down and we get it what, students, finally? So sine theta is equal to 2 by 3. And finally, we got the answer. So we take a sine inverse. So let's take a sine inverse. 2 divided by 3. And I'm getting 41.8. So 41.8. So I hope so. The point is very, very clear. And let's go for next part. So second part, he's saying it is given instead the plane is rough now. Rough, okay. Theta is 30, is changed. First I got 41.8, now change. Acceleration of A particles 0.1. And we need to show this coefficient of friction is this. So mu value, we need to prove this one. So let's see. Okay, Bismillah ar-Rahman ar-Rahim. Let's see. Situation is I erase this. You can make this diagram in exam, two separate diagrams, okay? And it means, so okay, I just erase friction only, and rest I think same. One extra part I will make it here. What is that? So this is a you see R. And what is this for students? You know it very well. Perpendicular, exactly one up and one down, exactly downwards. What is this? This is a mg sine theta, this mg cos theta. But theta is given here 30. So I will use 30 now. Okay. I erase this theta. I erase theta. Okay. And I write 30 here. And I 30 here. So I think, okay, let's see, 30. Yes, 30. Now, the same story will apply here. So first of all, he's saying very clear, acceleration of A upwards is a 0.1. So this acceleration is going upwards. So friction will be downwards. Same, it is going downwards. Acceleration is equal to 0.1. So let's start from here. What is the formula for B particle? So let's start with B particle. Or I can say, first of all, A part we can apply even, but tension is there, so we can solve tension using them simultaneously. Okay. So first of all, I can say for a B particle. So B particle, net force is equals to MA. How many forces acting downwards? It does downwards 20 M, upward tensions 20 M minus T equals to MA. And M is what? 2M. Acceleration is 0.1 given by him. Okay, I'll recheck. Mass is 2M. Correct. Correct. So I got it. And this is so it means 20M. So I think I can make it easy. I make T subject, T goes there, and this comes this end. And 2 times 2, 0.1. And this value subtract from 20. So we got 19.8 M. I recheck 20 M minus 2 times 2.1. Yes, students, correct. So this B particle done. Let's talk about A particle. So is system going upward? So I will start again, same formula. Net force is equals to, whenever you confuse, apply this formula, you will get easily. Above force 1, 2 force acting downwards. So tension minus friction, tension minus friction minus weight component. And what is weight component? 30 M sine 30. 30 M sine 30 is equal to mass is a 3M, acceleration is 0.1. So tension, this is coming here. I'm getting 19.8 M. Friction is interesting now. Friction, we don't know. Okay, I do one thing. Friction, bring on the right hand side, and 30 M sine 30, I'm keeping it here. Even this also bring left side. I get what? Negative 0.3 M equals to friction. This friction, I got it here, and this value I bring left side. So see, M, M, M. So I can type all together, okay, and but because I have to get exact value, so please don't try to type it. Okay, and what is friction? Friction formula is F is equals to mu R, and mu is unknown, and what is R? R is this. So I'm copying 30 M cos 30. This value I will take from here. And for your knowledge, I think I can type 30 times 2 cos 30. It's giving me 15 root 3 times 2 mu. 15 root 3 times 2 mu. And what about this? I type in calculator. So 30 times sine 30 is half. I got a 15. So 19.8 and minus 0.3. You know, student, this and this are subtracted. And I'm getting what? 19.5 M. And this I get what, students? Negative 15 M. I'm close to my answer. So, and what is a mu? Mu value is, so I missed one thing here. This M is missing. This M is missing. M times 2 mu. Yes, now okay. So M times 2 mu. M times 2 mu. Student, look at here. It means right and left hand side 19.5 minus 15. I get 9 by 2. What student I get? 9 by 2 M. Here 15 root 3 M times 2 mu. So mass and mass cancel out. This will go down. And 9 I already have 1 over 15 root 3. So when you type in calculator, so what I get? 15 root 3. Although I can manually even, but I got it what, students? 1 over 10 root 3. Alhamdulillah Rabbil Alamin. Same thing to target? Yeah, same. So Alhamdulillah Rabbil Alamin, proved. Okay, let's go for next part. The next part, what is asking here? When B reaches a floor, when B reaches the floor, it means B will hit the ground. The length of, find the length of time. So, and B reaches the floor, come to rest. All right. and find the length of the time when B after B reach the floor after. So it means I will start my counter, my time watch, my like timer will start when B will reach the floor, and for which A moving up the plane. And is interesting. The same concept, student, movement due to inertia, students. I discussed before. Remember here. Come back. This is movement due to inertia. Same again concept is coming. Logic. How I know when this B will hit the ground, okay, and it will travel how much, student? 0.8 meters. It will move how much, student? 0.8 meters. When it will reach here, it will reach here, zero point 0.8 meter, 0.8 meter. But do you think it stop here? No, it will go slightly up. This is called movement due to inertia. And this time he is asking for, he said, when we reach the floor, it means starting from there. Find the time after. B reached before and A move up the plane. So it means the plan is very clear. So I hope so. You got the point is very clear. So let's try to fulfill the demand. How we can do it? So let's see how we can plan. So first of all, we know 0.8 meters will moving downwards. It will move upwards 0.8 meters. So let's make a plan here on diagram. No problem. So first of all, it will move 0.8 meters. Then it will go, this is motion due to inertia. And then it will stop on the top. So it means last velocity is 0. Okay. And but problem is that we must need this time is my concern. Okay, students, and we need some data. Data was data number 1 is what data required. We are looking for this velocity number 1. We're looking acceleration number 2. If I have, I think I can get my answer. So let's start. First number, final velocity when it is moving. Look at students. So first it is going from here to there, then here to there. And this is the last velocity. This is inertia. Last velocity be 0. Okay. Now for B particle, I am finding for B U 0. S is, I think so, 0.8 meters. And acceleration is 0.1. 0.8 meters, acceleration 0.1. I will find last velocity. So 2as is equals to v square minus u square. 2 times 2 0.1, s is 0.8 meters. Last velocity concern u0. If I find the root of this, 2 times 2.1 into 0.8. It is giving me 0.4. 0.4. You know why this is important, students? Because the last, it's starting from here u0. It reaching at this moment, last velocity is 0.4, is 0.4. And this will become u for the other motion. So now I talk about for a inertia motion. So u becomes 0.4. This velocity become u. For your knowledge, I repeat again. Look at it. It will travel downwards. It will travel this way. What is speed here? Same speed here. So just before hitting this speed is zero point 0.4. So just reaching here 0.4. So speed at this moment and this moment same for A and B together. Afterwards, it's not after hitting the particle earth, the situation will change afterwards. So I hope so clear. So now last velocity on the peak must be 0, and acceleration is my first task and time is my second task. He is asking time. Now, students, that situation is very important. You remember, I found out the first, this is tension, this is friction, this is weight component, and that is a 30 m sine 30, if you remember. Okay, and net force equals to ma. You know it very well. Applied force, this tension minus friction minus 30 m sine 30 equals to MA, 3MA. Let me check. 30 minus, what is 30? 30 M sine 30, correct. 30 sine 30, right. So students, have a look carefully here. But tension, is become zero. Why? Because when a particle hit the ground, no tension remains. Friction is, we have it. Friction, we have it. Okay. Friction, what we got it, I will plug in same friction. This is a very interesting negative. Okay. And I'll plug in friction from where? Friction from here. 13, 15 root 3, 15 root 3. M times 2 mu. And what is mu? I got it, students. I got mu is 10 or 1 over 10 root 3. This is a friction. And what is the one? Sine 30 is half. I got a 15m. Here, 3m acceleration is my concern. So I think I should type it. 15 into 3 divided by 10. Yeah. I got a negative 9 over 2, negative 15. And I think I can cancel m. So students, I think you got it. And negative 9 over 2, negative 15, and divided by 3. So acceleration is coming negative 6.5. This is the most important thing where students get issues. Okay, I hope so you got the acceleration very clear. And now I'm going to finalize. Okay, student, let's start. So what is that? V is equal to U plus AT. V is top 0, U 0.4, acceleration negative 6.5, and time is my concern. So if I find the time, so it means 0.4 divided by 6.5. And I'm finding it, 6.4. This is 1 minute, please. Let me check. Yeah, 0.4. So, Alhamdulillah, Rabbil Alameen. I'm trying to display, please. Yeah, so I got time 0.0615 seconds. So Alhamdulillah Rabbil Alameen. I hope so. The complete paper is clear to you. And just pray for me. Best of luck for exams. See you inshallah next time. Allah Hafiz.